Hello and welcome back to Blueprints Academy. I hope you all are doing very well. And today I welcome you all to our episode 3 where we're going to be writing the actual ETL code. In the last video, we discussed how you can create a local development environment for your testing purposes. And if you didn't get a chance to watch that video, I highly encourage you to go and watch that video so you have an idea where we are in our journey of building real world data pipeline. But anyways, if you didn't get a chance to watch that video, it's still fine. You can continue watching this video because here we're going to be writing actual code and I'll just give you an overall view of what we did in the last video. So before we start, a little introduction of myself so you know who is your speaker for today. My name is Aditya and I have over 7 years of experience working in software engineering and data engineering combined. Currently, I'm working for one of the leading marketing company in Europe and I am based in Germany. Before we actually start to write, let me just give you a recap of what we discussed and what we are actually trying to build. So this is the architecture which you see on your screen. It's simple, it's easy, and it is literally using just one thing which is called Lambda. So all our ETL code gonna be residing in Lambda. But if you see clearly, if you see a bit deeply, it's a event bridge rule, which is going to be triggering our Lambda every 5 minutes. And this Lambda would be pulling data from an weather API and then pushing it in the form of JSON to S3. Now, the another Lambda would be reading this JSON file, which is nothing but the weather update in JSONs and doing some kind of a transformation and then pushing it back to S3. Now on S3, we're gonna have Athena running so people can query the data and do whatever they want to do. So it's literally this simple. So I hope you understand this architecture, and if you have any doubt or anything in your mind which you wanna ask, just do write in the comment and I would be very happy to reply back. That being said, now is the time that we should start coding. So here I am in my IDE. This is the folder structure. We discussed this folder structure. We created this folder structure in our last video. If you didn't watch it, I'll just give you an overall view. So this is the ETL package. And then we have corresponding packages, which we believe would be useful in our development. This is a folder. This is gonna be used for our infrastructure code. We would be mainly using Terraform in this series. So not yet, but in the next video, you're gonna be see how we're gonna have our infra deployed using Terraform. This is for the test. This package gonna have our test classes and test utility things for our project. This is the environment file. Here I am keeping some AWS related configuration because we wanna test everything locally. So we need this information somewhere. I thought to have it in environment file. You can use n number of different ways, but in this series we're gonna be using .environment file, and on AWS of course everything happens via IAM, so you don't really need all this hard coding stuff there. So this is just for our local development. This file is having Python version which is 3.12 that we are using. This is the Docker file. This is the file we're gonna be using to test our Lambda locally. This is the project.taml, which is gonna be our main file for the build of this project and managing dependencies. README, as it says, it's README. It has nothing at the moment. And this is the uv.log. So this is the folder structure. Now let's write a little bit code. So first thing that we need is logging. So what we say is def get logger, and we say name equals underscore name, and we want to import login. Now here we say logger equals get logger, of course, and if not logger.handler, if we don't already have logger running, we're gonna create a logger with log label equals os.getenv.upper. Now of course we need to import os. Let's import it. Now we have the log handler. Now we need the handler, and we don't really need system.stdout. By default it's system.stdout. We also have handler. We also need formatter. Here's the formatter, handler.set formatter, and logger.set log label, logger.add handler, and finally we return logger. Simple, easy. So this is our simple logging file. This is gonna be used in all of our code. Now, next thing is ingestion. This is our first lambda. This lambda gonna be pulling the data from weather API and pushing to S3 in the form of JSON. Let's get started. Lambda handler, we need logger.info, not received event, but we would say it job started, because we are not actually kind of expecting any kind of event here, so it does not make sense to have that kind of an logging information. And from etl.logging.logger import get logger, and you say logger get logger. Now we need couple of things, and the first thing that we need is API endpoint, right? Because that is the place from where we're gonna be pulling the data. So the API endpoint, I'll just give you a brief introduction of the endpoint that we are using, so you know which endpoint we are using. So this is the website weather stick, and we are using this API to pull weather application data. I already have my access key, because in order to access this data you need to have access key, and it's free. So it's literally free. You can just sign up here and get your key and use it, at least for testing purposes. It has some limit, I think 500 API calls a month, but I think it's good enough for our use case. We just want to test the architecture, right? So you can just create your free account and get the API key and then use it in your code. I already have mine, so shouldn't be a problem. And then we're gonna have an API endpoint where we're gonna be pulling data from. So if you see, this is the API endpoint, this is my access key. So of course you would be thinking that why I am using it as hard coded. So as I said, this is just for development purpose. In production, you would really want to use a system manager or secret manager or some kind of a config, or even in a encrypted form, this kind of information. But for testing and development purpose, I think it's all good. And query equals to Berlin, which means that we want the weather data for Berlin. Now we have the API endpoint. We also want S3 bucket where we're gonna be pushing this data, and for me it's blueprints academy data lake, and then it's os.environ, and it should be coming from the parameter, and we say this. And what happened to this? Okay, all good. And let's import our OS so it does not give an error. S3 key, where we're gonna be pushing this data, so it's gonna be raw/weather/timestamp. Now the timestamp, we will have to create timestamp equals to datetime dot utc now dot string format. I think this format is fine. Let's from datetime import datetime. So we have all our variables. Now is the time to write our code, which is going to be pulling data from the API. Now we need try, of course, because we are calling an API and we expect some kind of exceptions, you know. Not this world is perfect. Let's say logger.info ingestion started, and now we say response equals to request.get API endpoint. We also need some kind of a timeout. Now we say response.raise for status, so we know what's happening. And also let's import request. Now once we have a response, we need this response in some variable, so we say response.json. Now once we have the data, we need to push this data, right? So push to S3, and for that we need a client which can connect our code to S3. For that we will be using Boto, so let's import boto3, we say s3 equals to boto3 dot client, not resource, otherwise it's gonna give you an error. We have a client, so s3 dot put object, and what do we need is like bucket key body format for y content type, sorry, and then we say logger.info ingestion completed, as simple as it looks. And we also need to have some exceptions as ingestion failed, and we also would like to throw an error, right? I would say return 500 with a body, the message, error, and error. In case of success, we would also like to return a success message, right? 200, not the body, but let's say ingestion completed. I think this should be all good. As simple as it looks like. So here we have our code which is pulling from the API, pushing to where? S3. Now is the time that we test. And how do we do that? It's coming from our previous development environment setup. So the thing that you need is you need to build this image, and to do that you can run this command. This should build your image, and of course, because it's Docker, you need to have Docker installed. This we discussed already in our last video, and it should be up and running on your system. Now once you build this image, you can just run this command. Where is that command? Yeah, this is the command, which is where we are passing this environment dev and environment file because we need this information. And then let's see, so now it's running. Let's invoke, and to invoke you can literally have like this, and it says unable to import module ETL lambda no module name request. Of course, because we are using request boto3, we did not edit them in our this dependency file. And how do you do that? Because we are using UV, you say UV add request, and you see it's here. Then you say UV add boto3. It should be here. It's here. And now since we change our dependency, it's gonna change our uv.log with new packages. We need to rebuild the image. It's a bit sad, but it is what it is. Let's build it again and run it again. And now let's see if it complains still. Okay, it did not complain. Status 200 body ingestion completed. So this works absolutely fine. All good. We're gonna be actually taking a look into this data on S3 just in a moment, but before that, let's think about our second lambda. So this lambda is actually doing what? Pulling data from an API, pushing to S3. Now we need to somehow have to inform the another lambda to do the transformation on this data, right? So how can we do it? We are not using any orchestration tool here. So the easiest way that we can do is invoking another lambda from the lambda. So what I mean, so once we push this data to S3, what we can do, we can actually invoke another lambda. Invoke, let's say normalization lambda. And how you can invoke is, so there is a way that you can invoke using a lambda client. So there's a function which is called lambda client.invoke, and here you need to give the function name. Let's say normalization. You need to say invocation type event. So why we have this as an event? So this piece is async, and we need to pass an payload. Now this payload could be something that we think gonna be useful, and in our case it would be a bucket and an S3 key. So we want to push this information to this lambda. So in the next step, when we write code for this lambda, we know which file to process. So payload can be payload. Oops, payload. Oops, payload. And variables should be lowercase. I know this. So let's make them lowercase. So yeah, and we can also log this. Oops. Ingestion, no, invoking normalization lambda for further processing, and here we can say logger.info invoking, okay, lambda invocation was successful. So as simple as it looks. So once we have this file written on S3, we're going to invoke another lambda which is going to do the transformation and put the file on S3 for our table to be created later. But at the moment we gonna just comment this piece, and you know why? Because we don't have this lambda and also we don't have the infra. So we comment it out, and we're gonna write our next lambda. So now we have our ingestion code ready, which is actually pulling data from weather API and pushing it to S3 in the form of JSON. Now we need to write our another lambda, which is gonna be doing some kind of transformation and writing this data in Parquet format on S3. We're gonna be doing that just in a moment, but before that, I wanna show you how this file looks like on S3. So let's go to S3. This is our S3, and if you see, this is the path where we are actually saving the data. It's under weather, and then if you see the folder, it's with timestamp. This is very important because we're gonna be triggering this pipeline every 5 minutes, so we need to have timestamp, and we of course don't want to override the weather updates, right? If I go inside, this is the file, it's JSON. I'll just download it, and let's just open it and see how it looks like. So this is how it looks like. I'll just copy this and open it in the JSON formatter so we can see it in a more beautiful way. So this is the file, and if you see, this is the request. It has a couple of key value pairs with the information that we requested. Then it has location, Berlin, country, Germany, region, latitude, longitude, time zone, local time epoch, and UTC offset. Current is actually having the weather information like temperature, weather code, observation time. It's all in UTC, by the way. At what time it was sunrise, at what time it's gonna be sunset, everything, air quality and all this stuff. So two main things that we should keep a note on. One is, if you see the structure of the JSON, it has request at the very parent level, then location and current. So if I minimize this, this is how it looks like: request, location, current. So in order to transform this, sorry, we need to read location and current and then do some kind of transformation, but you're gonna see it in just a moment. So now let's go back to our code and let's create another Python file, which is gonna be normalization.py, and what we need is def lambda handler. We need a logger, so logger equals to get logger, and this logger we can import from login.logger import get logger, and name. Now logger.info received event. Now this time we need to have this logging because we're gonna be having this event here, and this event gonna be having these two values, bucket and the key. So once we have our event, we're gonna get this value from the event. So we say event of S3 bucket, and key would be event of S3 key. Now what we want to do is process this data, right? So let's write that code. Try logger.info processing. Okay, now the first thing is that we need to read this data because this data is residing on S3. And how can we read it? is of course via boto3. So we need s3 equals boto3 dot client s3. Let's also import boto3. Now once we have a client, what we can do is response equals to s3 dot get object. Once we have a response, we need to convert this response to a variable, and this is how we do. But this response gonna be a JSON. So what we're gonna say, JSON dot loads. Now once we have this data, we need to do some transformation, right? So let's say we have a method called transform this raw data. So we're going to be writing this logic of transformation just in a moment, but let's do some transformation. I'm just writing a pseudocode here so it's easy to navigate and understand. Now once we do the transformation, what we want to do is we're going to be pushing the data to S3, right, again. But since we are not using a Spark, we don't have a direct way to actually push this data to S3. So here we're gonna be leveraging pandas. And how we do it, like we say pandas and pyro, because if you see this data frame, it's not actually a data frame, but it's just a JSON record. But later this method gonna be, sorry, the function gonna be returning us a pandas data frame. Now the pandas data frame does not have a predefined function to push this data to S3. So here we're gonna be using something called pyarrow. And how we're gonna use the pyarrow is like this. So we say import pyarrow as PA. Now in pyarrow, what you would like to do is create a table first out of this pandas data frame. And how do you do this is like this. So pa.table from pandas, passing the pandas data frame. Now once you have a table, you need to create a buffer out of it. So we say parquet builder equals bytes IO. Now once we have a byte IO, what we can do, we can use pyarrow to save this table as a parquet on local before pushing it to S3. And how we do it is like import pyarrow dot parquet as pq, and pq dot, there is a function called write table. This table is the table just created by pyarrow, and this is the buffer, and the compression we would like to say snappy. And you would also want to import this bytes IO. So now we have this table, and now what we can do, we can actually write this table to S3. Now before writing, we need a path where to write, and actually this data gonna be partitioned hourly. So we need to have this key kind of defined in a way that it has that information. So we say processed whether, then hour equals to, now here we want to put this hour value, right? And how we can do it, like we have a data frame df.ilocate, locate the column at 0 index, and the column name is hour. Now the thing here to note is this hour needs to have a value, right? What if this hour is empty for some reason, or null for to say, it's gonna cause the problem in our partition. So it's gonna be good thing to do something like pd, which is our data frame, is na, and we actually check this value before actually using it for our partition key, right? So we say if it's na or empty. If it is, then we say raise value error, and we can say you need to have an hour with a legitimate value to to go ahead. Something like that, legitimate, what is the spelling? No idea. Legitimate. Okay. Hour with a valid value. That makes things more easier. And now after hour, what you need is like data underscore the name of the file, right? And this file name would be dot parquet, of course, but here what we're gonna do is gonna concat timestamp, and that you can do by timestamp dot utc now dot string ftm, and then you can just pass whatever format you like, and from datetime import datetime and strf time, and this could be percentage y. I mean, I have this very common format with me. I'm gonna use the same one here, this one, and dot parquet. Now what do we need? Now, okay, we also need to import pandas, of course. Import pandas as pd because it was giving error in this place. Now we have a partition key. Now what we can do is like s3. Again, we need the, oh, we already have the client. Okay, so we need s3 dot put object bucket partition key body. In this case, it's gonna be dot get value, and what else? Content type as parquet, or you can have application slash octet stream, and after that you say return, and what do we say? We say status 200 body partition key, and that's it. Or maybe a message data successfully processed. In case of exception, you wanna return with body error processing failed. Simple. So this is a simple example, and here you would like to pass df, and so this is what it's doing. It's reading this file, doing some transformation, and writing it into s3 as in parquet. Simple. Now we need to write this transformation function. What we can do is like create a file in this utils folder. Let's call this file helper, and write this code here. So we're going to be doing everything with pandas. So let's say pandas as pd, and data frame transform raw data. Now what this method gonna do is first we need to, if you remember the structure of our data, it has request, location, and current. So what we wanna do is like get this location data, current data, and do the transformation on this, right? So let's do first thing, location data equals raw data, or for a better way, dot get location or empty, and similarly current data equals current. Now what do we need is like record equals, we need to create a record in a way that we want to consume or provide in the downstream process. So some important thing that we can have is like timestamp, and this we can take from location data dot get local time. This is actually written already, this transformation, so I'll just do a copy paste here to save our time and your time as well. So here I'll say location data, so location data, and this is current data. So now we have a record. Now once we have a record, we can create a pandas data frame out of it, right? And it would be like df equals to pandas.data frame from dict, and you say like this. And now df of timestamp, we need this timestamp value because we want hour out of this, right, for our partition. And hour gonna be df of timestamp dot hour should also work, but let's make it more clean, and we say this with percentage ymd and t and hour. So we have a quite a good name on the folder, and then we say return df, all good, and that's it. And now here we import this, so let's import, and that's it, simple as that. So we are reading this file, processing it, and putting it onto S3 partitioned by R and in the Parquet format. Now it's time to test. To test, the first thing that you have to change is this thing, because earlier it was using ingestion lambda as an entry point. Now we need normalization. And by the way, yes, you can just avoid this change here, and you can pass this file name when you actually run this Docker image, but it's easy to just rename here for the moment. And now we gonna do what? We will build this image as always. Once we build this image, we gonna run this image. And how do you run? You run the way you were running before. Now it's running. Now we need to invoke. Now the invocation command is actually a bit different here, and you can already guess why it is, because this lambda assumes an event with these two keys. And that's why if you see, this is the event with the name of the bucket and the key, and now we run it. And of course it says no module name pyro. Of course, again we need to add uv add pyro, and we also need to add pandas, and we also have to rebuild, sadly. Let's rebuild this and test. Let's run again. Let's test again. So now if you see the message data successfully processed, partition key at this path, all good. Now let's go to S3 and see. So here we are on S3. Let's go here. Okay, we have a process folder with weather, and this is the partition, and it has the Parquet file. All good, nice. So you see, we have our both lambda up and running. One is pushing data to raw, another one is pushing it to processed. Now what else? So we have both the lambdas up and running. We tested them locally, all good, all fine. What we can also do, if you see, usually these two lambdas do not require any kind of test, because usually what we test in unit testing is the logic, the business logic that we are doing to make sure that we don't make any mistake when we do changes in the future, right? But in this case, we are actually doing nothing. We just call an API, we push that data to S3. So we don't really need a unit test for this lambda. And similarly, even for this, because here also we read this data, we do the transformation and push back to S3. So don't really need an unit test for this lambda as well. The only test that I can think at the moment is to have for this helper method, because here we are doing a couple of things which makes sense to have some kind of test. So now we're going to be writing some unit test in this folder, and to do that, let's just get another file called test helper.py. Now this file would have mainly two tests, and one test would be to test helper, or let's say test transform basic data, let's say. Another method would be having test transform maybe missing data in case we get. Now to test the basic data, what we need a raw data in the form of dictionary, and we need couple of things. So I already have this mock data with me, so I'll just copy paste that data to save time. So here's the mock data with location and current information. Now once we have a raw data, what we want to do, we're gonna just call our transform method, right? That's how we do the testing with raw data. Let's also import this thing, and now once we have this result, we're gonna do some assertion. So first thing that I'm gonna check if is instance of a data frame. So if df is a pandas.data frame, which, because this is important because we are assuming in our code here that this method returns, this function, sorry, returns the pandas data frame. So one test could be this, and of course you need to import pandas as pd. Another thing that you can do is assert df.shape equals to 1, because we just have one record, to be honest. What else? You can actually test all these fields, but does not make sense because we are not actually doing quite a crazy transformation here. So I think these two assertions are enough. We need the similar data, not similar, but because it's missing, so we say raw data equals location as missing and current also as missing, and then we again called our transform, and then we do is instance again, it should still, and it should be 0. I think that's it. We can just test this, but actually if you see it is still not gonna be 0, because we will still get this data but with everything as null. So what we can do, just we can check one thing as pd dot is na, and what you would be interested to check is a row, and to get the row, what you can do is like row equals df dot ilocate 0. It's gonna give us 0. Now we can say row of for example anything. What do we have here? Let's say temperature C, for example. It should be NA, right? Because there's no data. So I think this should be okay. You can write n number of cases, but here I can think of two. One is missing, one is with the data, and we don't really have much of a transformation here. So it's good to just have this test. So that's it. Now we have a unit test. We have our actual code for the lambda, and we also tested it locally and it's running fine. Now in the next exercise, what we're gonna do is we're gonna write some Terraform code where we're gonna be building infrastructure for our use case, and then once we have the infrastructure, we're gonna be deploying all this on AWS and running this as an whole data engineering pipeline. So that's all I had for you today, and that's it. Yep. So if you like this video, do like, share and comment, and also please feel free to share your feedback if you think there can be things which could be improved, or if you think there might be a more simpler way to do the things which I was doing in this video. And until then, have a good day and bye bye.